I'm working on converting this old Push Maxi into an e-moped. That's pretty much just like a regular moped, but dressed all in black clothing. In this video, I want to get this industrial robot battery adapted and fit onto the moped. The problem is the motor and controller that goes with this run on 48 volts. This battery's only 36 volts nominal, so it's going to take some reconfiguring. But before we do that, a couple of things before we get too deep into this. First, the thumb thing. I did a previous video on this, but I hurt my thumb right around the time I started making this video. You'll get to see the whole gamut of various splints and such. It's doing better now, it's not 100%, but it is healing. Thanks for asking. Secondly, I don't know everything. I did a lot of research and homework before I jumped into this one, but I'm sure I did something wrong. Overall, don't consider this to be a how-to as much as a how I did it. Playing with batteries is obviously dangerous. If you know more about working with these batteries than I do, and you see something I could do better, leave me a nice, respectful comment. Yeah. I got this battery from batteryhookup.com. I'll leave a link and discount code in the description. They deal with surplus and salvaged batteries. This one was new in box, never been cycled, basically brand new. This is some Topdon tape. Normally you would use Kapton tape, but I opted for the generic version. This is the battery management system board. It's going to be proprietary and it's also for 36 volts, so not really useful for what I'm doing here. These black wires might be for thermistors, I'm not totally sure. So what we're left with is 110 of these 21700 cells. This is a 10S, so 10 sets of cells in series, 11P, 11 in parallel. What I want to do is arrange this into a 14S, 8P. So 14 cells in series, 8 cells in parallel. And if you're better at math than I am, you already know that I have 110 cells here, and I'm going to need 112. But since these are new uncycled cells and they're name brand cells, I picked up 2 more of them. I also want to split my battery pack in half so I can have half on one side of the frame and half on the other. So make 2 7S 8P modules. If I can, I would like to minimize the amount that I have to disassemble this. This is just a little prying tool from a smartphone repair kit. Plastic. I've got the nickel strips off of both sides here, to the point where I can lift this up and sneak these cells out. But then I realized I don't really have a good way to store these. I don't want to just throw them all in a box loose. That seems like a bad idea. This is some Delrin that I picked up at a yard sale. All I can say about that is if you see a listing for a yard sale with a whole bunch of machinist tools, you should probably go hit that one. So all of these are reading exactly the same voltage. They're all 3.55 volts, except for the two that I'm adding. They're 3.6 volts. We'll deal with that in a minute, but for now we're going to set these aside. To get rid of the part of the battery holder I don't need anymore, I've got a fence set up on the bandsaw so I can't cut over into the batteries, and I've got a piece of plastic on the bottom to insulate it from the table. So the more I've been looking at this thing, thinking about trying to split off 3 sets of cells here and make 2 battery packs, I think I'm going to be better off making 1 battery pack, kind of rearrange some cells here and maybe move some here and make 1 battery pack. I mocked up the general shape of it with some foam on the moped and generally like the idea, but before I commit to it, I think I'll make the battery box. I'm going to hammer form these, and regular viewers will recognize that I'm reusing some pieces of treadmill that I'd used in my video on hammer forming panels for the Jeep. One of the things I've kind of come to appreciate with doing sheet metal work is a lot of times it looks really terrible until all of a sudden it doesn't. You just have to kind of keep working and reworking it. The lid for it still needs a little bit of refinement, but I think that looks pretty good. Made some little spacers, put them back behind there, and then I made another one of these for right there. I'm going to take this opportunity to spray some Anchor Lube all over the place and then thank them for being an awesome supporter of my channel. I used an end mill here to create something that's halfway between a counter bore and a spot face. I did the front mount for this in 2 pieces. My idea is to make a mounting system for this where I can take the battery box off without entirely disassembling the rest of the moped. I'm happy with that setup. Let's put a battery in there. I've got the 3 parts of my battery here, and they fit in there pretty well. The next thing to do is make the 3 pieces into 1 piece. Of course, before I glue this all into one block, I want to get all of these cells ready for reassembly. We'll start with these 2 cells that were the new ones that had higher voltage. Even though there's not a big voltage difference between these, if I connect them, because the resistance is so low, there will be a very short burst of very high current, which would be bad. So we'll add in some resistance in the form of a light bulb. This is about 0.6 of an ohm, which should give me just a little over 5 amps. The other thing is, as the light bulb heats up, the resistance increases, so it's sort of self-limiting a little bit. I've also got my thermal camera. This is the Topdon TC005. I've shown this before. Just to keep an eye on it. There's no reason this should be heating up, but if I start seeing something weird going on, I can stop. So we can get these down to 3.55, which is what the other ones are. They kind of keep coming back up as they sit a little bit. But what I can do is, before I make the final parallel connection, I can just balance it through the light bulb. You can see on the camera here, those 2 cells are slightly warmer, but not a whole lot. The ability for this thing to pick up very small temperature differences like that is pretty incredible. I mean, I can't even feel that. I've also got a few more cells that I'm working on charging up, just using it to keep an eye on those. Again, nothing exciting, which is good. And in preparation for welding on new nickel strips, I have to clean off the remains of the old ones. Very carefully using a Dremel to do that. That's all glued up pretty solid. So the next step is going to be to spot weld some nickel strips on to make all these connections, which means I need a spot welder to do that. I'm doing a capacitive discharge spot welder. I found the design for this on Hackaday, and it seemed like a pretty simple design. I'll leave a link in the description to the plans. So I've got 15 10,000 microfarad capacitors all arranged in parallel. There's also some bleeder resistors here. This just discharge the capacitor slowly if it sits for a while. A couple of output wires, a couple of input wires. Now I need kind of all the rest of the controls for it. And I think I want to make a box for it before I start trying to hook this stuff up. Got this little USB-C input jack that I need to attach in here. I'm going to temporarily hot glue the cord in to hold this in place. And just a little bit of epoxy on here, should be good to go. It's a little dual relay board. I added some capacitors and resistors to it per the instructions for helping with the way that it charges and discharges. I went ahead and got all of this wired up off camera because otherwise it looks a lot like the back of my hand. So doing my best to explain this, we have our little USB-C port here. That means you can either run it off of a USB-C wall wart or one of the little battery packs, make it portable. Power comes in, goes to our relay module. In the normally closed state, it runs through the relay to this constant current buck boost converter. I have it set to pull 5 amps, otherwise it overwhelms the power supply. This converter lets you adjust the voltage and adjust the overall power, and then feeds it down into the capacitor bank. When you hit the little trigger button, it triggers the relay, stops charging the capacitors, and the other relay sends a signal over to this thyristor, which then dumps all of the current out through the leads to the welding wire. For now, I just have a light bulb on there, so press the button, light bulb lights up, and then it recharges. One of the capacitors added onto this relay module causes a delay. You can hear it click open and closed. And that lets the thyristor fully dump all of the current before it starts charging again. Of course, now the question is, does it do what it's supposed to do? I've got some 0.15 millimeter nickel strip here. That didn't spring as much as I thought it would. Jeez! Okay, so that was turned up all the way. Yeah, so that blew through that. Let's go to 20 volts. I'm going to play with this for a bit, bring it back in. So it seems like I can do 30 volts, which is full power. If I hold it at a little bit of an angle and make sure I have good contact. Seems pretty good. Let's make a battery. These nickel strips should be good for about 5 amps each. I'm sizing the battery, maximum draw will be about 40 amps, so that means 8 strips per series connection, or 1 strip per cell. Because not all of the series connections are running across straight parallel lines, I've kind of had to fudge things around a little bit, but I kind of kept to that 8 strips per series connection rule. One thing I will say about this is with that limited power supply, it does take a long time to recharge. Might need to look into a different power supply for it. Alright, I went ahead and finished up this side of it. I've got my BMS leads all tied into the existing wiring and wired into this side of it. Onto this side, I'm soldering the BMS leads on before I spot weld the strips on. A couple of changes to my setup. I swapped out the USB power supply for this one. It lets me run a little higher amperage. There's still something in here that's cutting off at about 1 amp, but that's still recharging twice as fast. I also wasn't happy with my homemade electrode, so I swapped it out for this one that I found on Amazon. This one even has a little micro switch there that triggers it, and I'm getting a lot more consistent results now. Since all of the current flows through the bus bars at the ends, I soldered some nickel strips onto some appropriately sized pieces of scrap copper. Since the copper sucks up so much heat, I used the torch and then kind of touched it up with the soldering iron. Before I connect the BMS, I'm going through and double checking the wiring on all of my test leads, make sure they're all hooked up right. Being very careful not to short anything here. Three and a half volts, 3.5 volts, 3.5 volts. All right, that all looks good. I'm using a Dali BMS on this. I'm going to put it right here. I've got it wired into my negative terminal, and I'm going to put the temperature probe right there. A little thermal glue. It's getting all over my hand. It's getting all over everything. I think I'm ready to hook this up and see if it'll activate. This is the one with Bluetooth on it, and I push this button, and I don't know if anything happened. Well, I've got 49 volts, so it's working. Let's see if I can figure out the Bluetooth part of it. Okay, so it's showing me all 14 battery strings, the voltages, temperature. Got to set the rated capacity. These are 5 amp hour cells, 8 of them in parallel, so 40 amp hours. Password, 12345 set successfully. There are no mounting holes on this thing, so I think I'm just going to kind of tape it all up to the battery pack. The purpose of the BMS is to monitor each string of cells and make sure that they don't overcharge or over-discharge, and also monitor the temperature and make sure everything's working properly and the battery stays happy. The BMS instructions say to fully charge it to the point of cutoff to calibrate the state of charge calculations. So I'm going to go ahead and do that now, and that way I can kind of keep an eye on it. The charger I got only puts out 10 amps, so it's not going to really stress this a whole lot, but it's a good start. So, charger's going. You can see on the app that we're currently charging at 10 amps. So we're now up to about 78% charged. We should start seeing the current drop off. I've also started balancing, and I've just been going over with the thermal camera, checking to see if there are any hot spots. Right now I have this set in the fuse mode, which shows a combination of the visible and temperature. That lets me see kind of where my hot spots are a little easier. And I have a few, but they're really nothing too major. Nothing that I wouldn't expect. That side over there is doing well. Topdon also told me that they have a Black Friday promotion coming up November 20th to 27th. I'll leave a link in the description if you're interested in one of these. So looking at just the straight IR mode, it's a little bit harder to tell what you're looking at. I find this color palette works well in the fuse mode. So I've now got this thing fully charged up. The way the BMS works on here, if one cell starts getting higher than the others, it'll discharge down to keep it balanced. So what I did was basically fully charged it, let it balance, let those high cells draw down, charge it again, let it balance, and just keep repeating that basically until the balance stopped getting any better. This BMS will balance it to within 20 millivolts. So this I think is all set, and next thing to do is mount it in the battery box. The threaded studs in the original case are just pressed in, so I'm just going to knock them out and reuse them. I cut a piece of plastic. This is ultra high molecular weight polyethylene. It's what I had on hand. Set that down in there to act as some insulation on the bottom. Someday I'll build something like this and actually leave extra space so that I can work around it. I drilled these holes at 1/4 inch, 250 thousandths. The inserts are 6 millimeter, which works out to 236 thousandths. If I do 15/64 holes through the sheet metal, that'll be 234 thousandths, give me 2 thousandths to press it in. So I'm just going to transfer punch these holes into the sheet metal. We'll just whip up a quick and dirty installation tool. Apparently that idea needs some refinement. Well, that fits. That's a good sign. We didn't really expect this would line up in there the first time, did we? These studs should let me line up the battery before I drop it in and guide it down into place. I did eventually get the battery down in there, and then I couldn't get it back out. I thread lockered some nuts onto the ones that I could reach to get them out, and then the other ones I pounded out. And then in the process, I realized this box is a little too small, it's a little too tight, and I wanted it to be a little deeper. So I made another one. Now the battery actually fits in there. For doing the little threaded inserts on these, I'm going to do what I should have done the first time, which is put one in, mark a second one, put that one in, and then mark all the rest and install those. I didn't do that the first time because the holes to the battery were only drilled out for 4mm screws and I'm using 6mm. But since I had to drill them out before to get it into the other one, might as well do it this way now. I cut a little slot in the top of these studs so that I can screw them in and out, and then threaded these coupler nuts on there. That gives me something I can bolt the lid down to. I just need to transfer the hole locations to the lid. I didn't have the right size transfer punch, so I just turned the head of a bolt down to a point. I only need one because I can just do it one at a time. These holes get M4 nuts welded on, and I managed to only weld 3 of the screws in place. And with the lid constrained a little better, I can do some hammer work to refine the corners. I did a whole bunch off camera because this has gone on for long enough. I got the brackets moved over, did some more just general hammer and dolly work over the whole thing, put in some holes for some little cable glands, had to notch out the top for those. I also added a bracket with some captive nuts because I've been binge watching Project Binky. And I welded in these threaded studs because I had a couple of them pull through. Should be pretty solid now. I think I'm ready to throw some primer on this thing. And since water and batteries aren't a good combination, I'm going over the seams inside and out with some seam sealer. This seems like a good time to address something that came up in the comments the last time, which is why didn't I bother to paint the thing while I had it apart? I mean, other than the fact that I don't really care what this thing looks like, this part serves as a pretty good example of why I didn't paint it yet. I don't want to paint this until after I seam seal the lid on, and I don't want to seam seal the lid on until after I test it, make sure everything's working right, and give it a good shakedown. It's the same story with the rest of the bike. I don't want to paint it until I'm happy with how everything's put together and working right. When you're fabricating one of these projects, paint's sort of the last thing you want to do so you don't have to work around it and try to avoid scratching it. Put some Anderson connectors on these so that I can disconnect it to take the battery out. Also put some on the end there for testing. I did end up having to play around with the lengths on some of these coupler nuts. Shorten some of them. Installing it that way makes sure that there's enough thread for the screw so it doesn't bottom out. Total, I think this thing weighs about 25 pounds, or about 11 kilograms. And if you're wondering what kind of range I'm going to get with this, so am I. And I think the last thing to do is to very temporarily zip tie the controller on, hook it up, and see what happens. Well, I guess this took me a lot longer than I thought it would. Unfortunately, there's not a whole lot of point in trying to finish this thing right now, so I think I'm going to shove it in the back of the shop and try to catch up on some other projects for a while. I think this thing's going to be a lot of fun once it's done, and it's doing a pretty good job of serving as sort of a dry run for learning and refining my skills for working on the Jeep. So if you want to see more of this stuff, stick around.